All right, so we are looking at our first lesson for algebra, college algebra. And the first part we're going to do is just to review some of the concepts that you've probably already talked about. So first, before we begin, I just want to go through and have you do a couple things quickly. So if you want to pause the video, I'd just like you to solve and graph, just a quick refresher. So when you look at this first equation to solve, you're going to add 6, so you have 2x equals 6, and you'll divide by 2, so you have x equals 3. Just kind of keep in mind, this is linear, and so linear, the highest exponent is 1, and there's only one solution. On the second one, if you simplify the expression, this is where we get into order of operations, which we're going to review today, but you've got to do the idea of PEMDAS, please excuse my dear Aunt Sally, parentheses, exponents, multiplication and division left to right, then addition and subtraction. So we're going to do the 12 first, minus 4 plus, and then we're going to do 10 divided by 5, which is 2. Then we're going to do addition and subtraction left to right. So if we go from left to right, we're going to go 12 minus 4 is 8 plus 2, and your answer should be 10. To graph the equation,
SST meeting in room 130. Again, SST meeting in room 130. Thank you.
To graph the equation, remember we have y equals mx plus b, where m is our slope and b is our y-intercept. So in our case, we're starting down at negative 6, and then our slope is 2, so we go up 2 over 1, up 2 over 1. And so this is a quick reminder, just a refresher, that if you think about the idea between to solve the equation and then when we graph it, remember over here on this one, there's a pointer. On this one, our answer was x equals 3. And if we go to the graph, we can see that right here, see how it crosses at 3. So a linear equation makes a line, just a refresher, and there's just one answer for x. Okay, so now, today we're going to talk about the real numbers. So when we talk about real numbers, first of all, we have subsets of them. And number one, our first part is counting numbers. Counting numbers are natural numbers, are like our natural numbers. They're sometimes called natural or whole numbers. And those are like your 1, 2, 3, 4, and so on. There's no fractions, and it does not have 0. Whole numbers, the whole numbers include 0. So it's 0, 1, 2, 3, 4. So the only difference between counting and whole numbers is the 0 is included in whole numbers. Integers is the whole numbers with all the negatives, if you want to think about it that way. So if you think about negative 3, negative 2, negative 1, 0, 1, 2, 3, and so forth. Rational numbers. Rational numbers are any numbers that can be written as fractions or a ratio. Okay, so any number that can be written as a fraction or a ratio. Such as like P over Q, but Q cannot equal 0 because you cannot divide by 0, so your denominator cannot be 0. And then finally, irrational numbers are real numbers that are not rational. So an example of that would be like the square root of 2 or the square root of 24. Those are examples of irrational numbers. The next piece is our properties of real numbers. So as we look at the properties of real numbers, first of all, we have our closure. The idea of closure is real simple in something that you've known from elementary school. Most of these, all these really are. A plus B is a unique real number. So is A times B. So when you add or you multiply, you get a unique real number. There's only one real number that it could be. Commutative property, we have it for addition and multiplication. A plus B is equal to B plus A. Also, A times B is equal to B times C. Associative property, I always think about associating or grouping, which involves parentheses. So if you have A plus B plus C with B plus C in groups, you can also do A plus B plus C and group A and B first. You can do it with multiplication too, where you can say A times B times C is equal to A times B times C, grouping, just changing the grouping. The distributive property is if you have A times B plus C, distributive property means that you can distribute the A into each part. So then that would give me AB plus AC. And of course, anything next to the parenthesis like that is implying multiplying. Part 2, the properties of real numbers. So here's some more of them. The identity property. The identity property is what gives back your original thing you started with. So for example, 0 plus A equals A. That's the identity property. Also, 1 times A equals A. That's the multiplication version. The multiplication property of 0 is the fact that A times 0, anything times 0, is 0. The additive inverse, A plus negative A, equals 0. And then finally, the multiplicative inverse is A times 1 over A, which then equals 1. That's the multiplicative inverse. So the properties of the real numbers, we want to complete each statement using the given property. So first, the commutative property. The commutative property, if you have x plus 7, then you can think of that as it could be 7 plus x. You can just switch it. Distributive property, if we distribute the 5 to each thing, then you have 5x plus 15. Associative property is just where we're going to change the grouping. So we're going to have negative 13 plus 4 plus x, but we're going to add the negative 13 plus 4 first. That's all the associative is. The properties of opposites. Okay, so for every real number, a and b, the product of negative 1 and a is the opposite of a. A simple example would be if you took 5 and then you took negative 1 times 5, you get negative 5. You get the opposites. And the opposite of an opposite of a is a. So an example of that would be, what's the opposite of negative 5? And the answer should be 5. And the opposite of a minus b is b minus a. Okay, so for example, if you had x minus 3, then the opposite of that, if you take the opposite of both things, then what that is, it'd be negative x plus 3, which is equal to 3 minus x if you then use the commutative property. If we just want to apply these properties of opposites, you can see that the two negatives are going to make a positive, and so this answer should just be pi. Here we have negative 1 times negative 2, again, should be positive 2. Two negatives make a positive. Here we're taking the opposite of x minus h. So if we distribute it, we have negative x plus h, which is equal to h minus x, which we can just switch them around. The properties of the absolute values. So the absolute value, when we think about absolute value, we really think about the idea of distance. So the absolute value of a is always greater than 0. For example, if I did the absolute value of negative 15, okay, that's going to equal 15, which is greater than or equal to 0. If I did the absolute value of the square root of 25, then this is the absolute value of negative 5, which is 5, which is still greater than or equal to 0. B is just saying that they're equal because the absolute value of negative a is a, which is equal to a. In here, it's saying you can split them apart. You can take the absolute value of each piece and then multiply them. And same thing with division. And then we have the exponential expressions. For any positive integer, n, a to the nth power means that it's a times a times a, n times. So a is the base, n is the exponent, or the power. So a to the n, this part here is known as the base. This part is known as the exponent. And the whole thing is an exponent expression. So exponential expressions and examples. So 4 to the third, if we want to realize what this means, it simply means 4 times 4 times 4, or 4 to the third power, which is 64. Now, number 2 and number 3, this is where we need to be careful, especially if you're going to use a calculator. When teaching geometry, this is one of the biggest mistakes students make. And the difference between these is think of it as -1 times 7 squared. Okay, so this is going to be -1 times 49, or -49. Number 3, because the negative is inside the parentheses, it's -4 times -4, which is 16. And then finally, the order of operations, you're going to do exponents first, and then multiplication and division left to right, addition and subtraction left to right. So as we look at the number 1, we're going to do any exponents first. So we're going to evaluate 2 to the third is 8, and take 3 minus 4 times 8. I'm going to do multiplication. Oh dear, where did that go? Oh no. Okay, sorry. So we're going to do the multiplication first. So we have 3 minus 32, which is then equal to -29. On number 2, we're going to do multiplication and division left to right. So actually I'm going to do 5 times 8, which is 40. Then divide by 4, then times 2. So we're going to get 10 times 2, or 20. Number 3, we just have all addition and subtraction. So we're just going to work left to right. 3 minus 4 is -1. So then we have -1 plus 9 minus 2. -1 plus 9 is 8. 8 minus 2 is 6. Number 4, as we look at this, we can look inside these parentheses here, and we can see we can't combine those. So we'll distribute the negative across. Anytime there's nothing there, think of it as like a -1. So I have -4x minus 6, plus 7x. So here I have 3x minus 6 would be my simplified form. Number 5, if I want to add or subtract fractions, you need to have like denominators. So I'm going to change the 1/2 to be 2/4 x minus 3/4 x. So I end up with -1/4 x. Number 6, I'm going to have -6x plus 18 minus 15 plus 21x. And so here I can take positive 21 and -6x to become 14x, and then 18 plus -15 to be 3. Finally, number 7, I'm going to plug in the values. So b squared, so -2 squared, minus 4 times a, which is -1, times c, which is 3. So I have 4 minus 4 times -1 times 3 is -12. So 4 plus 12 is 16. The law of any two real numbers for a and b, either a is less than b, a is equal to b, or a is greater than b. And we just want to make sure you know these numbers, and they have all sorts of fun rules about, the alligator eats the bigger one or whatever. So we have less than or equal to, we have greater than or equal to, greater than, and then equal to. With that comes the laws of reflexive, symmetric, and transitive. Reflexive is that for any real number A is equal to itself. Symmetric would be that if you have A equals B, If you have A equals B, then B equals A. You can flip it around and it stays equal. Transitive, if you have A equals B and B equals C, then you can say that A equals C. Take out the common link like from geometry. And then substitution, just meaning you can substitute in for something. The absolute value of A is the distance from A to 0 on a number line. So the absolute value of A is going to be A if A is less than 0, and it's the opposite of A if A is less than 0. The distance between two numbers on the number line is just the difference of them, and you take the absolute value. So, for example, if I have on a number line, here's my 5, here's 25, here's 0, then if I want to find the distance, I can take the absolute value of 5 minus 25. I could also take the absolute value of 25 minus 5. Either way, my answer is 20. And that completes the lesson for today.